In this tutorial, we'll review the process for finding inverse normality, or the z-scores given in an area, and the area under the normal curve in SPSS. For this example, I'm going to be using a data set that's in SPSS already called world95.save that gives demographic statistics for 109 countries around the world. The first thing I'm going to do is I'm going to get a standardized score, a z-score, for each of the countries on one particular variable. I'm going to be looking at the life expectancy for women in that country. And I do it this way. The easiest way is to simply go to Analyze, to Descriptive Statistics, to Descriptives, choose my variable, average female life expectancy, put it over here, and click this box that says Save Standardized Values as Variables. And when I click that, it's going to give me some descriptive statistics, and I don't care about those. What I want to do is I want to go back to my data set, and here at the very end, it's created a new variable called zLifeXF. That stands for the z-score, or the standardized variable for the life expectancy for females in countries. Standardized scores have a mean of 0 and a standard deviation of 1, and they're a very convenient way of comparing the scores of each other. So for instance, this first country, which is Afghanistan, we see that the life expectancy for women in that country is only 44 years. It's very short. And given the statistics in this particular data set, that would give them a z-score of minus 2.47. That is, their life expectancy is almost 2.5 standard deviations below the mean. It's very low. This is one way of looking at the relative value of the number. Now, sometimes you also want to look at what's called the cumulative distribution function, or what percentage of the distribution is below a particular z-score, as another way of getting a percentile-based feel for the relative standing of a number. The way to do that is to come to Transform to Compute Variable. I now get this box, and I need to type in the name of the new variable that I'm going to use. Because I'm going to be doing z-scores, or rather the cumulative function for the z-scores, I'm going to give it this rather long name. I'm going to go zLifeXF.cdf, for cumulative distribution function. Then what I'm going to do is I'm going to come over here to the cumulative distribution function group, and I'm going to say, what if I'm dealing with a normal distribution? Since I'm using z-scores, that's a logical way to do it. And come down to here, this one, and I'm going to double click on it. And then it's going to ask, what variable am I using and what's the mean and standard deviation? So I need to come down to my newly calculated z-score variable. And if I double click on that, it inserts it right here. Then I need to manually insert the mean and the standard deviation. However, because I'm using z-scores, the mean is 0 and the standard deviation is 1. That's true by definition. So I click on that now and hit OK, and it will give me a new variable, and this is my output. This tells me what it just did, and if I go back, I see that I have a new variable right here with probabilities. They go from 0, which means there is none of the distribution below that, but with a normal distribution that's really not possible because it's asymptotic, up to 1, which would mean all of it is. Again, not really possible. But here you see, for instance, that with Afghanistan, where the average female life expectancy was only 44 years, that gave it a z-score of 2.5 standard deviations below the mean. Less than 1% of the entire distribution would be below that. So it's right at the bottom. On the other hand, we take this score, we have a 458 there, and that's Bulgaria. Bulgaria is about half of a standard deviation above the mean in terms of female life expectancy, and about 2/3 of all countries you would expect to have lower life expectancies than Bulgaria's women do, which, by the way, is 75 years. Anyhow, that is one way that you can calculate inverse normality and the area underneath the normal curve to examine variables and get a good feel for their relative standing in SPSS.